first derivative of this function with respect to x, which will give you 2x. Then you get second partial of function u with respect to x, which will give you 2. Then after that, you find the partial derivative of u with respect to y, which will give you negative 2y. Then you get the partial derivative of u with respect to y, which will give you negative 2. Then you check Laplace equation, which tells you if you have the first derivative of second derivative of u with respect to x plus second derivative of u with respect to y, I think should give you 0. In our case, you have 2 minus 2, which is equal to 0. Now, to check whether this function is, to find it is harmonic, it is to check the Laplace function, which we have done here, and hence it is harmonic. Also, you could be given this function u is equal to cos of y multiplied by a parabolic sine of x. So you will have u with respect to x, which will give you cos of y, a parabolic cos of x. Then the second derivative of u with respect to x, it will give you a cos of y, a parabolic sine of x. Then you could have a partial derivative of u with respect to y, which will give you f of x. Then the second derivative of u with respect to y, it is going to give you negative cos of y multiplied by a parabolic sine cos of x. Note that this one is cos of x. So the next step is you check whether second of this with respect to x plus second derivative of u with respect to y is equal to 0. In our case, we have this cos of y multiplied by a parabolic cos of x plus minus cos of y multiplied by a parabolic equal to 0, meaning that our given function is harmonic. So you could have this function v is equal to y squared minus x squared. So to check whether it is harmonic or not, all what you need to do is, first of all, you get v with respect to x, which will give you negative 2x. Then you get the second derivative of function v with respect to x, which will give you negative 2. And from there now you obtain the partial derivative of v with respect to y, which will give you 2y. And you get the second partial derivative of v with respect to y, which will give you 2. The next step, you check whether partial derivative of v with respect to x plus partial derivative of v with respect to y, the second derivative, is equal to 0. In our case, we have negative 2 plus 2, which is equal to 0, meaning that our given function, this one, is a harmonic function. So thanks so much for taking your time to study with me on how to find whether the functions are harmonic or not. exercise, you check whether this function u is equal to sine of y, hyperbolic cos of x. You check whether it is harmonic or not. And also, this is A of this question. B, you check whether given u is equal to hyperbolic sine of y, then cos of x. You check whether these two functions are harmonic or not. Int, you are going to get passive of u with respect to x. You also get second derivative of passive of u with respect to x. And also you get partial derivative of u with respect to y, together with the partial derivative of u with respect to x. Then you compare whether partial of u with respect to x plus partial of u with respect to y is equal to 0. In case you get your result is equal to 0, then it follows that A and B are harmonic functions. In case it is not equal to 0, then it means they are not harmonic. So thanks so much. Remember to subscribe to the channel so that you don't miss a single video which I upload for us every day. Bye bye. See you in the next presentation.